Good day to everyone. My name is NAJIEHAH AZWA BINTI Maksai. My matrix number is F25A1621. I am from SFA program. Also, I am the leader of this group. Today, I will present my topic is fresh fruit punch growth dynamic. This project combines bioscience, agriculture, and calculus to study the growth of palm fresh fruit punch, also known as FFB. First, I will explain the bioscience problem that we choose. In Malaysia, oil palm is one of the most important agricultural industries. The fresh fruit punch goes through many biological chains for pollination until maturity. The main problem is that planter needs to know the best time for harvesting and the stage where the fruit grows the fastest. If harvesting is too early or too late, the oil quality and production can decrease. Our project studies the growth of FFB over a 24-week development period using a logistic growth model and derivative. The logistic growth model shows how the fruit weight increases slowly at first, then rapidly and finally slow down near maturity. The derivative function helps calculate the growth rate every week. This study is important because it helps improve plantation management and oil palm production. By understanding the growth pattern of FB, planter can predict fruit growth, manage nutrients properly, choose the best harvesting time, and improve oil quality and yield. From analysis, the fastest growth happened around week 11. At this stage, the growth rate reached about 1.9 to 5 kg per week. This means week 11 is most active growth period for the fruit punch. Now, I will explain the section in our web page. Scenario background. This section explains the biological background of the project. The web page states the FFB developed over 24 weeks and follow a logistic growth pattern. It also explains the three important growth phase. Late phase from week 0 to 6, peak gain for week 10 to 30, oil maximum from week 20 to 22. This phase helps users understand the development process of the fruit punch. Logistic growth curve and derivative. This section explains the mathematical model used in our project. We use a logistic equation to calculate the cumulative fruit. This section contains an interactive graph. User can move slider to analyze growth at different weeks. The graph shows cumulative FFB weight, growth rate per week. The graph clearly shows that the growth rate reached its highest point around week 11. This makes the web page easier and more interesting to understand. At week 11, estimate FFB weight is 11 kg. Growth rate is 1.9 to 5 kg per week. The derivative trend shows peak mass accumulation. The web page also explains that is an important stage for yield development and nutrient management. Lastly, we include reference for trusted scientific sources as MPOB core guidelines, PMC journal article, and lastly MOHD growth model. These references support the accuracy of our project. One recommendation to improve this web page is adding more advanced features such as replantation data, weather monitoring, AI prediction system, and better mobile responsive. This would make the project more practical and interactive for users. In conclusion, our project combines bioscience and calculus to study the growth dynamic of oil palm fresh fruit punch using logistic growth and derivative help us understand the fruit development process and identify the fastest growth stage. Thank you for listening. Now, I would like to pass the presentation to the next presenter.
Hi everyone and good morning. My name is NURAIN. I'm BINTI Mohamad KHAIRIL and my number is F25A1555. Today I want to share about our project called Harum Manis Mango Calculus Growth Rate Simulator. Basically, we are using calculus to see how Harum Manis Mango grows over 12 weeks. So, what is the problem here? A Harum Manis mango takes around 12 weeks to grow and is follow an S-shaped curve. The tricky part for farmer is they cannot guess how fast the mango grow, how fast a mango grow just by looking at the size. Size alone does not tell us the inside speed, so farmer might miss the best time to care for the fruits. Why do we need to study this? When we use a calculus, we can find the exactly week when the mango grows the fastest. This peak time is super important because it tells us exactly when to give the best fertilizer and enough water to get a beautiful grade A mangoes. So valid, if you want to know valid growth reference is from MOHD Crop Research Bulletin Harum Manis Penology and Department of Agriculture DOA Perlis Harum Manis SOP. So we go to this part. To this model, we use the logistic growth model. The weight is called is f of x, and the maximum size is 400. This is 400 maximum target. 450 grams. To check the growth speed, we use the derivative called f prime of x. This is derivative f prime of x. This formula shows that the mango grows very faster in the middle and slow down at the end. So we can go at the graph. So we can go at weight. Start with the weight 0. Started with weight 0 and go to weight until weight 3. So until weight 3, the weights f of x are and speed f prime of x are almost 0. This is the very beginning where the fruit is just taking, is just starting to form after pollination to the line is flat. That's why line is flat. So we go to weight 6.0. So click in the middle of 6 on 0. This is the most important weight. The mango is 250 grams and the speed hit the absolute peak of 67.5 grams per week on this graph. In this graph, 16, it's 0.5 per week. This is the golden time for a farmer to give extra water to high potential spray. So we go to week 10 until week 10 until 12. The weight reaches its maximum limit 450 grams and the speed drop back to 0 to the mango stop growing bigger and is now just getting sweet and ready to harvest. So on this graph we can see how long the Harum Manis mango to take time to be getting sweet and ready to supply. So this graph also show us when we can pick the mangoes. So if you guys want to pick the mango, you have to make sure you go to week 12 to pick the mango, the Harum Manis mango, so that you can enjoy the fruits. So harvest maturity and sugar accumulation, we are at week 12. The S curve has flattened. The growth rate f prime of x is nearly 0.7. The mango is not longer gaining weight. Is the covered stores touched into sugar accumulation, volatile organic compounds, and making harmonious uniquely fragrance. And after that, you can enjoy the fruits. So, to make this HTML website better, I recommend adding a color alert system. Right now, it's only show a static number when we move the slider. It would be cool if the screen changed the color green to orange or pink when the slider hit the peak weight from weight 5.5 to 6.5. This will easily alert farmer that it's time to take action. It's time to take action for take or pick the mango. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. My name is NURAIN SHAMIMI binti Malaysia and I am an agro-technology student. My entry number is F2581573. So today I would like to present my Bioscience HTML project titled Using the First Derivative to Optimize Processing Timeline for MD2 Pineapples in Malaysia. For this project, combine Bioscience, agriculture and calculus to study pineapple growth pattern using mathematical model and derivative. So, the Bioscience problem chosen for this project is determine the best growth stage for MD2 pineapple plant before flowering induction, also known as forcing. In Malaysia, MD2 pineapple is an important commercial crop. Farmer needs to ensure the plant reaches a suitable biomass before forcing is carried out. If forcing happens too early, the fruit may become smaller and lower in quality. However, if forcing is delayed too long, production time and cost may increase. Therefore, monitoring plant growth accurately is very important. In this project, the first derivative is used to analyze the plant growth rate and identify the faster growth period of the pineapple plant. This study is important because it helps improve agriculture efficiency and crop management. First, it helps farmers determine the best timing for forcing to produce more consistent fruit quality. And second, understand plant growth rates can improve overall yield. Third, farmers can manage resources such as fertilizer, water, and labor more efficiently. So for this project, also show how calculus and derivative can be applied in real agriculture situation. So the explanation of the HTML project. A Bioscience problem section. The first, this section explains the agriculture issue faced by MD2 pineapple farmers. This project states the pineapple plants need to reach approximately 2.5 kg before flowering induction is carried out. This section also explains how derivatives are used to monitor the plant's growth rate and help determine the best timing for forcing. Next is the MD2 plant growth curve simulator, which is the main feature of this project. The graph contains two lines. So the first, the green line represents plant biomass or total plant weight, and the blue dot line represents growth velocity, which means the growth rate per day. The x-axis shows the number of days of the planting, while the y-axis shows plant weight and growth rates. So from the graph, we can see the plant biomass continue to increase over time, while the growth rate increase until a certain point and then gradually decrease. When we click on the graph, the microanalysis engine displays detail of information for a select date. For example, like day 240, the cumulative plant weight is 1,400 grams. The instantaneous growth rate is plus 10.50 grams per day. This shows that the 240 is the faster growth stage of the pineapple plants. This point is called the inflection point, where the first derivative reaches its maximum value. After this stage, the plants still grow large, but this growth rate starts to slow down. Illustration is display the mathematical formula using the simulation. The first formula, the biomass function fx, which model the total plant growth over time. The second formula is the derivative fx, which calculates the instance growth rates. In calculus, the first derivative represents the rate of change. So in this project, derivative help calculate how fast the pineapple plant grows each day. One recommendation is improve the HTML project is by adding more interactive features such as a hover animation, automatic pop-up, expression, and mobile-friendly responsive design. Another improvement is adding real agricultural data for Malaysian pineapple from the increased accuracy and reliability. So in conclusions, this project is successfully combined Bioscience, agriculture, and calculus in one interactive HTML applications. It demonstrates how derivatives can be applied in real agriculture situations to analyze plant growth and improve farming decisions. This project also helps users understand the importance of mathematical in bioscience and crop management. So that's all for me. Thank you.
Hi, Assalamualaikum and good evening to my students and lecturer. My name is Mohamad Yazer bin Rosaidy. My matrix number is F25A1874. I'm from course Animal Husbandry. So today I will explain about the graph given is based on my course. The title given is Applied Calculus in Animal Husbandry. So as you guys can see on the graph given on the share screen, the first presentation is about applying calculus in animal husbandry, specifically analyzing broiler chicken growth using derivatives. So this project uses mathematics to understand how chicken grows and how farmers can improve productivity. So the problem is farmers need to know how fast chicken grows and when is the best time to harvest for maximum efficiently. We use a function to estimate chicken weight over time. The derivative shows the growth rate, which is the daily weight gain. The graph shows that growth increase fastest over time, not constant, as we can see in this graph. Okay. For example, we take day 1. At day 1, the chicken weight 46.5 grams and grows at 8 grams per day. So as we can see description, layman explanation. At day 1, the broils weigh 46.5 grams. The derivative is 8 grams per day. So this represents the brooding pace where rapid structural and internal organ development is occurring. The feed provided must be high in protein to support this daily weight gain. So this will help the farmers make better decision about feeding and harvesting. So as we can see in this graph, this graph given is the curve is increasing and getting steeper. This means chicken grows slowly at first day, but it will grow faster as they increase. This is typically in biology growth acceleration pace. Okay. At day 1, the chick is still small, but it's already growing at 8 grams per day. This is the early development stage. Okay, I will explain how this help in farmers. Farmers don't just care about weight, they care about the efficiency. It helps the farmers monitor growth performance, optimize feed conversion ratio, detect when growth slows down, decide the best harvest time. So, the Bioscience scenario in Malaysia, poultry farming, monitoring the growth curve of broiler chicken. Example, COP 500 grade, over day standard 42 days, cycle is critical. Farmers need to know not just the total weight, but the daily weight gain, DW, to optimize the feed conversion ratio. If the growth rate begins to the plate while feed consumption remains high, it marks the optimal time for harvest. As we can see, we use this formula to mathematically modeling total weight function grams a day x. We use this formula fx equals 1.5x power 2 plus 5x plus 40. So the growth rate derivative grams per day, we use this formula fx equals 3x plus 5. So the data source, this data source is based on Malaysia Poultry Standards, DVS, simulate but realistic form data. So I will make a summary of this presentation. The formula predicts chicken weight. So we use this formula to predict the chicken weights and how it grow by daily. Second is a derivative shows growth speed. The third one is a graph visualize the growth curve. You can see the graph. It will by day it will grow. So all used to improve farming decision. I will hope my presentation is easy to understand for you and it helps the farmers. Thank you.